Hi everyone, here comes your next lesson. We're going to talk about approximating solutions to systems of equations. This one's going to be a really easy lesson because it's all calculator. Okay, you're going to be doing all of these in the calculator and you're really just going to be figuring out where your solutions when you're graphing a system or two different equations. Just find their points of intersection, okay? Just know that approximating solutions, remember your solutions are your points of intersection. So some of these, you don't have beautiful points. If you notice, look at number 1, you see a lot of decimals. So it's not going to be, where you could graph them and see the perfect points. You're going to touch on your points of intersection, find where they intersect. Your point of intersection is your solution, and then you're going to have your answer. Now, just be aware of the first question when they give you two different functions, f of x and g of x, and then they say, for which the value of x is f of x equal g of x, okay? So really important. They are only, when you see this, they only want the x values. That's all they're looking for, okay? So I'm going to go into GeoGebra for you, okay? And if you notice, first thing you're going to do is type your quadratic x squared minus 2x minus 8. Okay, there's your first graph. Change my color. And then I'm going to do the second one, which was 1/4 x minus 1. Okay, and there it is. So everybody should see your 2 points of intersection. Here's one of them. Negative 1.75. Okay, negative 1.4375. So I'm going to write that down. Negative 1.75, comma, negative 1.4375. But remember, there's another solution. Your other solution is this point of intersection, which is 4, 0. Okay? So there could be a lot of confusion. These two are the solutions, but because this question is only asking for the x, for which value of x, they're looking for this value and this value, okay? And again, just take note, they want the x values, so your answer should be negative 1.75 and 4. Straight GeoGebra, straight calculator, okay? All right, I'm going to scroll up. I don't know how this happened, but if you take notice, numbers 2 and 3 are exactly the same. So you only have to do, obviously, one or the other. So I'm going to just cross out number 3. Because you don't have to do that. Okay, so it says what is one of the solutions to this equation? And again, I'm going to go straight into GeoGebra. I'm going to get rid of everything in there, and I'm going to type my first equation. Notice I don't write y equals. I write negative x squared plus 5. There it is, your concave down parabola. And your other one is negative 0.5 x squared plus 3. Okay, and again, you can move things around, but there's one of your points of intersection, negative 2, comma 1. So I'm going to write that, okay? I'm going to write solutions, and one of them is negative 2, comma 1. So my other solution is right there, is 2, comma 1. And they just are asking, what's one of the solutions? One of the solutions is right here, negative 2, comma 1. How easy. Okay, I'm skipping 3. I'm going to go to 4. Okay, if you guys look at number 4, you have two different functions. You have an absolute value function, so just take note of what you're looking at. Okay, this, I'm going to put absolute value, should look like a V. And this one is just linear. Okay, when those two functions are graphed on the same set of axes, which statement is true? So the first thing I'm going to do is graph them. I'm going to graph absolute value, so let's get rid of these. Absolute value of x minus 3 is one of them. And your other one is 3x plus 3y equals 27. So there's your line and your absolute value. And I'm just going to bring it in and look. And I wanted this to happen. So when you notice this, everybody sees that point of intersection there, correct? But when I keep touching on it, I can't get the point of intersection. This happens sometimes in GeoGebra. If that should happen to you, where you can't touch and find the point of intersection, click on the circle triangle, and right underneath basic tools, you see the word intersect, okay? Take that intersect and touch on the point of intersection. When you go back to your calculator, you'll see that the point of intersection is 6, 3. Now, the other nice thing you could do, this happened to have been an integer, you could see it's hitting right at 6, 3, but that's a possibility that could happen to you. So just take note that your solution is your point of intersection, okay, point of intersection, which here is 6, 3. So look at your first thing. It says, which statement is true about the solution? 3, 0 is a solution to the system because it satisfies the absolute value equation. Well, it's not a solution to a system if it doesn't satisfy both. That makes no sense. 9, 0 is the solution because it satisfies the linear function. Again, that doesn't make sense. If it's a solution, it has to satisfy both. 6, 3 is the solution to the system because it satisfies both. Has to be it. But let's just double check the other. 3, 0 and 9, 0 and 6, 3 are all solutions because it satisfies at least one of them. What's 3, 0 and 9, 0? Well, if you look here, there's 3, 0. It's a root. Has nothing to do with the solution. It's not a solution to the system. And even 9, 0 is the y-intercept of one of them, but it's not a solution because it has to satisfy both equations, which would only be the points of intersection. So that's why clearly your answer has to be choice 3. Okay? And again, you could prove it by literally plugging 6, 3 into your x and y for each equation, and you would see that it would satisfy both. Okay. Let's see, how many do we have left? 5 and 6. Okay, so I think I'm going to do one more with you. This is a good one, number 5. I definitely don't need you to sketch it, so I'm going to just ditch that part. You don't need to sketch your solutions, but I'm going to give you just a little hint on a couple of these questions. So this one, you're asked to graph these two functions, and they say, find all solutions where f of x is equal to g of x round to the nearest tenth. Okay, so we are going to find all these solutions. So I'm going to go back into the calculator, okay, and clear it out. And my first one is x to the third plus 2x squared minus 2x minus 1. So there's my first. Hopefully you know this is a cubic function. How do you know it's cubic? Highest exponent is 3. Okay. Your next function would be just this linear function, 4x plus 2. Okay. So we're going to look, I'm going to sketch, I'm going to pull in, because you really needed to look when you kind of move your graphs around, how many points of intersection do you see? You actually see 3 points of intersection. Now this question is a little bit confusing. I want to say something very important to you. It says find all your solutions where f of x equals g of x. So you are going to state all 3 solutions. So I'm going to start with this one right here. Now look at these numbers, pretty crazy. You're going to round, they tell you to round to the nearest tenth. So I'm going to say negative 3.5, comma, negative 11.9. So here's one of your solutions. Negative 3.5, comma, negative 11.9. There's one of your solutions. Next solution, that's a root. We don't want a root. We want, get a little closer. I keep touching on the root. I need that point of intersection. See how the root and the intersection were very close? Be careful. I would say negative 0.4, comma, 0.2. I'm going to write that one down. Negative 0.4, comma, 0.2. And then that last one, which is all the way up here, that point of intersection is 1.9, comma, 9.7. So 1.9, comma, 9.7. Now here's the crazy part. This says find all solutions where f of x equals g of x. Okay? So that means they don't want the entire solution. This f of x equals g of x means they only want the x values, okay? So technically, your answers are when x equals negative 3.5, when x equals negative 0.4, and when x equals 1.9, okay? These are your answers. So you have to be very careful. If they just say find the solutions, then the points of intersection will be your solution. But if they say where f of x equals g of x, you're only going to state the x values. Okay. In number 6, they didn't say anything about only the x values. So in number 6, oh, they did. Take note, you just want the x values. They want you to round to the nearest hundredth, and I'm going to leave this one to you guys. I'll post the answer key, but I'm going to give you a hint. There should be 3 points of intersection. Okay, so I'm going to leave you number 6. I'm going to leave you number 7 and number 8 for you guys to try on your own, okay?